Hi, this is Henk Akkermans and this is Supply Chain Dynamics Chapter 5, Sysdea Gameplay 2, the second pencil shop example. Well, it's the same pencil shop, but we add a little more realism to it. The lack of realism, at least that we have here, is that when we are short on pencils, we can immediately replenish them. In reality, often there's some kind of ordering delay or a pipeline delay, as I say. Well, a pipeline is really a stock. So let's call this indeed the pipeline stock, and let's make sure that that's connected to this one. You see again here that it gets quickly negative, so that's not what we want. We want the inflow of pencils to be up here into the ordering process up here, and so we need some kind of a pencil ordering rate, if you like, the pencil buy rate. So far so good, but how many will we buy? Well, of course, again, as many as we expect to sell. Well, some improvement here, but still not enough. Why? Well, we have the inventory corrections halfway in between. Let's first of all also correct this one here, because now the pencil arrival rate is no longer dependent on the sales rate. It's now not a pull, but it's a push. So it depends actually how much there is in stock over some kind of a delay, a pencil arrival delay, let's call it like that. Oops, I mean arrival pencil or pipeline delay. And let's make that again 2 time periods. We then have a pencil arrival rate, not of these things, but and also not of the inventory corrections. But we have a pipeline stock divided by the pipeline delay. That's a first order material delay. This one indeed we no longer need. We still need the inventory corrections though, but those go now in here. So the pencil buy rate plus is the expected sales rate plus the inventory corrections from the final inventory. That does get better. You see a nice amplification here, and part of the reason is that we do not account for the pipeline stock up here, and we should. There should also be pipeline corrections. So let's see if we can make those pipeline corrections. Again, the corrections are the difference between the current stock and some kind of a target, as we have here, target inventory, but now we want a, keep doing this, a target pipeline. And how much would that be? Well, as often, how much you normally would expect to sell, but also how long that the pipeline, how many days inventory will travel through that pipeline, 2 days. So we have also a target pipeline here. The pipeline stock corrections then become the target pipeline minus the current pipeline, and this then goes into the pencil buy rate. Look how very interesting our behavior is becoming. It will become less volatile if we put this up, but nevertheless still very interesting. So I have this resolution here. What do we see now? We see that the pencil arrival rate Oh, sorry, we forgot one thing. Of course, the pencil stock should be from the beginning. Oops. Good. No. Yes, good. Should be from the beginning at the level of the target pipeline. You incidentally also see here how helpful it is if you initialize stuff in steady state. If I now, for a little while, make this 0, then everything is smooth. So we can see that everything that changes in the behavior of the model is a result of this single step increase. And what do we see then? Well, the most interesting one is actually this one now, because that's the one we want at the beginning of the system. We now see that if pencils are underway for 2 days, that when we actually need 20% more, we will actually buy 100% more, not 10, but 20, an amplification ratio of 5. Every step in the process makes perfect sense. Together it looks a bit silly if you need 2 more to actually then next period buy 5 more. Of course you can say, well, perhaps we shouldn't be so eager to correct all this so very quickly, but that's a matter of choice, of course. This here in itself seems fair enough. Just to check, suppose that we would make the step increase a -1. Then the same effect will occur, only the other way around. We then would see that sales in the next period would actually drop to 0, which is pretty much what happened in the electronics industry in 2001 and again in 2008, that because of a decline of 20% all the way down at the end of the supply chain, where consumers didn't buy as many electronics goods as they did before, upstream in the supply chain, this resulted in a total breakdown or stop of sales. This example neatly summarizes very complex industry dynamics.